The following podcast is sponsored by StructureTech.
Well, Minnesota has pretty strict regulations when it comes to electrical work. So it's a matter of educating and informing people to what's allowed and what's not allowed.
Welcome everybody. You're listening to Structure Talk, a Structure Tech presentation. My name is Bill Ulrich alongside Tessa Murray and Ruben Saltzman as always. And on today's episode, we're going to be talking to a person. His name is John Williamson, and he works for a large agency here in the state of Minnesota and has a lot of knowledge about electricity. And on the podcast, you'll notice that we love talking to our building officials. And I'd say John's a building official, but I'm going to let him introduce himself and tell us all about his credentials just the way he sees fit. And we're going to do a deep dive today in electricity. Because the last time we had a building official on, Andy Schrader, he voluntarily admitted that electricity is not in his wheelhouse. Andy Schrader with Rum River Consultants. So we turned to a wonderful resource in John Williamson. And John, I'm going to go ahead and ask you to introduce yourself and kind of give us a little bit about your background.
I'm not a big fan of lengthy bios, but I've got 43 years in the electrical trade. Master electrician, I'm a certified building official. And yes, I do work for the state of Minnesota, but I'm here today speaking just on my own. I'm not speaking on behalf of the department. I'm just a resource for you guys and for your audience, just like I would be for anybody else. So that's about it. I mean, I started out 2 years of trade school, technical college. It's kind of interesting. I listened to the podcast with Andy Schrader, and Andy and I kind of have a lot of similarities. 2 years of technical college, went through the BIT program, 11 years as a electrician foreman, master electrician. I got into inspecting in 1988. Worked for a private company. We did general inspections in several suburban communities, including electrical, building, plumbing, on-site sewage treatment systems. And then I had the opportunity in 1994 to go to work for the state where I could focus just on the electrical, which is obviously my passion. Now I'm looking at possible retirement. So, yeah.
And John, I know that you're not doing anything with any capacity for the state today, but
Right.
Just to make it clear, what is it that you do for the state?
My working title is Electrical Operations Supervisor. So I was the Chief Electrical Inspector, but Dean Hunter is now the Chief Electrical Inspector. So Dean Hunter and I co-supervise the entire electrical inspection program in the state of Minnesota. And we kind of split it. I handle office operations and Dean handles field operations. So Dean oversees most of our field reps and all of our contract electrical inspectors. We have 65 under contract currently, and we inspect every corner of the state, all the way from the Iowa border to, if you're building a cabin on an island in the middle of Lake of the Woods, we'll get there somehow.
I've got a bazillion questions for you, John. If it's okay, we'll just dig into it. We've got a time constraint. We've only got you for another 35 minutes, and I want to get as much of this covered as possible.
Yeah, actually, I'm on vacation right now. I blocked out this part of the day just for you guys. So.
Oh, you're such a sweetheart. Oh, my goodness. Thank you. Oh, that means a lot to us. Get someone like you on here, man. This is something that I know your answer to this. You have come and talked at home inspection seminars for us, and you've been gracious enough to email me really detailed answers to this question, but I still get other home inspectors asking me about it. This is a problem all over the country. It's a problem for home inspectors here in Minnesota, and it's where they do a home inspection, they take the electrical panel cover off, they write stuff up inside the panel, and then later on they get an electrician who has a conniption fit and says that it's illegal for home inspectors to remove panel covers and that, you're breaking the law and this is electrical work and you're not authorized to do this. What do you have to say on that, John?
Well, Minnesota has pretty strict regulations when it comes to electrical work. But I can tell you emphatically that removing a panel cover is not a violation of any law, rule, or ordinance. It's certainly a safety issue, but it's not a legal issue. So it's a matter of educating and informing people to what's allowed and what's not allowed. The removing a panel cover to do a visual inspection or to do some voltage readings or just to look inside the panel There's nothing illegal about doing that in the state of Minnesota. It's no different than opening the cover on a disconnect switch to take some voltage readings, or opening the electrical access on a appliance, or replacing a light bulb, or replacing a cartridge fuse in an old fuse panel, or a little fuse stat. Those are all just everyday tasks that any service technician can do, or the homeowner can do for the maintenance of their own property. Again, safety is paramount, but it's not a legal issue at all.
Okay, that's fantastic. Thank you. Let me ask you this. This one is a bit of a curveball. I sent you some of the stuff that I wanted to talk about ahead of time, but here's an odd one. What if I'm opening up an electrical panel and it happens to be one of those Federal Pacific electric panels? I take the cover off and then I get a handful of circuit breakers that just fall out of the panel. Don't ask me why I might suggest that scenario. What would be the best course of action? And you know, maybe you could say you don't know. I don't mean to put you on the spot. It's okay if you say you don't know, but I've had this happen. And it's like, what do? Do you shut the power off? Do you leave the panel exposed? Do you pop the breakers back in? Now that's doing electrical work. I mean, what now?
Yeah, that's a great question. I don't know if that's a curveball or a slider or a spitball. It's a good one. You know what? I kind of just thinking on the fly here. You know, for anybody that has any electrical knowledge, I think we have an obligation individually to report that. Even if you don't have the tools or the training or the license to fix what you just found, at least you have an obligation to report it to the property owner or to whomever. But in the case of something like that, that could happen. You could open up a piece of electrical equipment and immediately regret that you even took that panel cover off, because you never know what you're going to find. I don't know if that answers your question or not, but
that's good. I mean, and we've had situations where we've backed screws out, and I kid you not, backing the screw out, shorted out with a live wire inside the panel. I mean, We've had plenty of situations or heard about it where screws going in pierce a wire, but backing out is just one that you could never possibly foresee. And it's just, it's scary stuff. And what do you do?
That happened to me, and I left it. I didn't want to touch it. I left it, and I called the seller and let them know, and they called an electrician. Electrician came out.
Yeah, you do have to have an electrician on speed dial for certain things that you run into, just for the safety of everybody involved.
Even as an electrical inspector, I learned early on in my career, I was ambitious. I was going to do a thorough job. And it's really embarrassing when you're checking the connection on a vent hood over a range to make sure that there's a connector on that NM cable where it comes into the back of the vent hood, and you want to make sure it's properly grounded. And you're taking these little screws out, and all of a sudden they drop down behind the range. And now what do? The homeowner's standing there looking over your shoulder. It went from inspecting this vent hood to pulling the range out, finding the screws. I mean, you gotta be careful what you get yourself into. But if it's a safety issue, you just need to report it up the chain of command, whatever that chain of command happens to be, or turn it over to somebody that can take responsibility for it and fix it. Yeah, I mean, our inspectors, they'll open equipment, especially in farmsteads and outdoors, and there might be a snake in there, there might be mice, there could be anything inside that electrical enclosure, whether it's in a house, in a barn, or outdoors somewhere.
I like how you say you might regret removing them. Cover.
Yeah, good. Next question here. Is it a bad idea for refrigerators to be plugged into GFCI-protected receptacles? And I'll elaborate on that question just a little bit. The current requirement for new homes when you're doing a kitchen is all those receptacles need to be GFCI protected. And a lot of people get a little freaked out about this because they're concerned that if you plug a refrigerator into a GFCI, at some point you're going to get this nuisance tripping where your GFI is just going to trip, and then you're going to come home after being gone for a weekend and all your food will be spoiled. So what do you have to say on that, John? What's the real deal here?
Well, I don't think it's a bad idea. I actually think it's a good idea. You know, if that refrigerator were to ever become an electrical hazard, I would want that GFCI protection there. And for my protection, or anybody's protection, I guess, I kind of surmised what led up to that question regarding unwanted tripping, as they call it in the industry. We prefer not to use nuisance tripping because whether it's a nuisance or not is, is subject to who's affected by it, I guess. They make GFCI devices that have audible alarms. They have GFCI devices that have LED lights. So if you had a refrigerator or a freezer or a sump pump plugged into a GFCI receptacle, and for some reason that receptacle tripped, you could be alerted visually and with an audible alarm. If you're not home, if you got somebody watching the house, you could clue them in on what to look for. But my brother shared a story with me not too long ago. He was working in a butcher shop and he went down to the basement. There was 2 freezers side by side. And unbeknownst to him, one of them, the outer shell was energized. He got knocked to the floor. If that happened today, that freezer was plugged into a GFCI, the appliance possibly would still be functioning, but it would have tripped when he became the path for that electrical current to that wet basement floor. So you got to balance it out. Is the loss of some groceries a real concern, or is it better to have that protection there all the time? The other thing I was going to say is, technically speaking, the refrigerator receptacle only is required to have GFCI protection if it's within 6 feet of a sink or if it's also serving the countertop receptacles. If it's not one of those 2 situations, technically it doesn't need to be GFCI protected. However, AFCI protection is required in kitchens, so it's more cost effective and it's more convenient for the electrical contractor just to put a dual function circuit breaker in the panel. That way, you've got both AFCI and GFCI protection for those kitchen brand circuits. That's typically what happens. A lot of times, it's just a standard receptacle, and the GFCI protection is actually provided by a circuit breaker back at the panel. So,
Gotcha. Thank you. That makes sense.
Hey, Ruben, you said receptacle, but why are you calling it receptacle and not outlet?
No good reason at all, Tess. Same thing. I should just call it an outlet.
I wondered if I missed something there.
As far as the 2020 NEC, I had some questions about that because originally it was scheduled to be adopted a while ago. We had, I think it was July or something, where we were going to adopt the new electrical code, but it never went through. There was some stuff that happened and it's in limbo right now. And I guess we're not going to dig into that topic exactly on why it didn't happen and when it's going to happen, because that's kind of an unknown. But something we will talk about today is the changes that are coming down the pipe, because we know there's a handful of changes. Well, there's a ton of changes. Usually when these changes come, I feel like most of the stuff that affects our day-to-day lives as home inspectors is just really minor stuff and we never notice. But there's always a few of them that are pretty visible. And I wanted to touch on a few of those.
Shocking changes.
John, do you mind sharing with us some of the stuff that's coming down the pipe?
Yeah, so kind of, these aren't in any particular order of importance, but it's just kind of, starting at the front of the code, working through chapter by chapter. There's a change relative to GFCI protection. So they removed previously GFCI protection was only for 15 and 20 amp 125 volt rated receptacle outlets. And now they've removed that voltage threshold. So the 15 and 20 amp threshold and the 125 volt. So basically they bumped up GFCI protection up to 250 volt rated receptacles. So what is the impact of that? That means that electric dryers and electric ranges will need GFCI protection if it's required elsewhere in the code. GFCI protection is going to be required now in all basements, whether they're finished or unfinished. We've gone back and forth on that so many times over the years, and at the end of the day, there just wasn't any practical way to decide what's finished and what's not finished. I mean, you could have a beautiful finished basement with just a painted gray floor, and somebody else might walk in there and say, well, no, it's not finished. We don't have any floor covering. Or you could have just the opposite. You could have a rustic basement that somebody might consider to be finished, but somebody else it might not be finished. So they just simplified it and they took away the criteria of whether it has to be finished or not. So it's just applicable to all basements. And again, if it's a finished basement, the branch circuits are going to be required to have AFCI protection anyway. So adding the GFCI protection is very simple. It's just replace that AFCI circuit breaker with a dual function AFCI GFCI circuit breaker. Minimal cost, $7, maybe something like that. That's an easy one, and that's going to eliminate a lot of arguments. The issue with basements, and I'm sure you guys see it a lot in your work. Have you ever went into a basement anywhere in Minnesota and not sensed some form of dampness? Or it's just very common. You can have intrusion of rainwater, snow melt. If you got poor drainage on the outside of the house, you can have water infiltration. There's hydrostatic pressure in the ground that forces water and moisture up through our basement floors. Things that happen inside the house that cause leaks. Basements, I got a full basement in my house, and I keep a dehumidifier and a couple of fans running all year round. And I have to do that to keep the moisture and humidity under control. So anyway, basements, GFCI protection.
Make sure I understand this. So also that would include AC compressors at the outdoors, right?
That's a separate issue we'll talk about.
How about water heaters, electric water heaters?
Electric water heater, GFCI protection, those typically aren't plugged into a receptacle outlet.
Oh, it's just receptacle outlets. Got it.
Yeah.
Okay.
Yep.
Understood.
Yep.
Thank you.
We're only talking about the GFCI protection required for receptacle outlets at this point with respect to the 250 volt situation and the basement situation. Moving on to arc fault circuit interrupter protection, there were not any changes in the 2020 code. In fact, the last major change goes back to the 2014 code when they added laundry areas and kitchens. There really hasn't been any expansion in AFCI protection for dwelling units in recent times. There have been in dormitory units and guest rooms and guest suites for hotels and motels, and now they've added AFCI protection for sleeping rooms in patient care facilities.
John, as long as we're talking about AFCI, I want to interrupt the flow there and talk about nuisance. Wait a minute. You said don't call it nuisance tripping. I think you said obnoxious tripping. Was that it?
Unwanted tripping.
Unwanted tripping. That's the word. Unwanted tripping.
Words.
It seems like we have the same issue with AFCI devices. And I bring this up because, there was a home I inspected. It wasn't all that long ago, just a couple of years ago. It was a newer home. It was built in 2016 or 2017, something like that. It was a time when you're supposed to have AFCIs installed in a lot of places throughout the home. And there wasn't a single AFCI breaker in the entire panel. And it had the inspection sticker on there. Someone inspected all of it, and I was just dumbfounded. And just said in my inspection report, it's technically supposed to have it in all of these places. Let me know what you find out. I told this to the buyer. Turns out the homeowner was having problems with unwanted tripping at different places in the home. And the electrician was out there so many times to figure out the problem and could not get to the bottom of it that they ended up removing all of the arc fault breakers and putting in traditional breakers. So I know that this is an ongoing problem with AFCIs. And I guess my question to you is, why is this still happening today? And what will it take to fix it?
Well, I think for the most part, I'll be perfectly blunt, the unwanted tripping issue is overstated. It kind of has a life of its own. According to the manufacturers and the testing laboratories, like Underwriters Laboratories, when you look at the industry in general, they have statistics available that show that given the millions and millions of AFCI devices that have been installed, manufactured and installed, the percentage of unwanted tripping is like 0.000 something, or I couldn't find the number. I had it here not too long ago, but it's really percentage level. It's really a small percentage. There's a website called AFCIsafety.com. And all of the competing manufacturers came together many years ago, created a website, AFCIsafety.com, where contractors and homeowners can report unwanted tripping. It's a great resource. Some of these manufacturers, if an electrician is truly stumped, they will send their engineers out. They'll fly them out to a housing development to solve these problems. I think the problem is overstated. Is it real? Yeah. Does unwanted tripping happen? Yes. I'm not going to say it doesn't, but the question is, why is it happening? And obviously today people want a quick fix. They want a quick solution. It's wrong, but it's really quick to just pull out those AFCI breakers and throw standard breakers in there and drive away and never have to get another recall back to that home. But you didn't solve the problem. Maybe the AFCI device was actually sensing an arcing current or arcing characteristic that was real, and maybe it was in the appliance. Appliances nowadays just simply are not the quality that they were years ago. Unfortunately, a lot of our appliances are disposable, not repairable. So to me, it's a matter of finding the problem and solving the problem, not circumventing or bypassing a very important safety consideration. The industry is out there waiting to help people. It just requires some resourcefulness, and it requires some time. Time costs money. I get that, but it's really about finding the problem and then fixing the problem in the right way.
I can't wait to get one of those engineer guys up to my place in Walker, because I think I've got all the nuisance tripping for the state of Minnesota this year. All the unwanted tripping on one particular arc fault in a condo, and it's this loft area, and it keeps happening. And unfortunately, the service panel is behind the locked door because this place gets rented out. And it's just one of those things that costs us a few bucks because the electrician has to come out and we get blah, blah, blah. But anyway, AFCI.com. I'm looking for one of those engineers. We'll get them a direct flight right into northern Minnesota.
I neglected to say something too here. I'm looking at my notes. GFCI technology came about in the 1971 National Electrical Code. So we've got 50 years of experience with GFCI technology. AFCI technology was mandated in the 1999 NEC with an effective date of January of 2002. So there was the Consumer Product Safety Commission was driving that bus. They were advocating for arc fault protection. So we've got 18 years of experience with AFCI technology. Rocky start when they started out, the compatibility with appliances. But, when you stop and think about other industries, aircraft and automobiles, computers, if you take any 10 or 20 or certainly 50-year period of time and think about the advances in technology, we've got almost 20 years of experience with AFCI, 50 years of experience with GFCIs. That technology, both technologies are well proven. Are there going to be hiccups? Yeah, there's going to be hiccups along the way. But the technologies themselves are well founded and they actually work really good. And it's hard to pin down when you have a safety device like airbags and seatbelts. Sometimes it's hard to quantify how many lives have been saved, how much property damage has been averted when you've got a safety device. So it's kind of hard to collect data for things that haven't happened, if you get my point.
Hey, John, can I ask you a question? And just because you mentioned something in passing, you talked about 125, 250 voltage, and I know years back it was referred to as 110, 220, and then it was 120, 240. We're talking the exact same thing, right? There's no difference.
Yeah. In the electrical code, the nominal voltage is 120, 240. That's for the purpose of doing calculations and design work. So if you're doing some sort of design work calculations, you're sizing a service or circuits or feeders for a building, you're going to use 120, 240 in all your mathematical calculations. The 250 volt, the 125 volt, I should say, and the 250 volt, that's the rating of the device. That's the voltage rating of that particular receptacle. So we're talking two different things. We're talking about nominal system voltages and the correct numbers to use when you're doing mathematical calculations versus the rating of the equipment. So take a disconnect for an air conditioning compressor on the outside of your house, depending on the make and model. It might actually be rated for sure it's rated 250 volts, but some of those smaller disconnects are actually rated for up to 600 volts, depending on make and model. So those are two different things.
Thank you.
All right. So sorry, I got a super sidetrack, John. We were talking about some upcoming changes. Left off with GFCIs, and you mentioned there's no big changes on AFCIs. What was next on the list?
Next on the list would be receptacle outlets for islands and peninsula countertops and similar work surfaces. So it used to be that you would calculate the quantity of receptacle outlets based on the dimensions of your countertop. 24 inches wide, it's 5 feet long. But they've gone now to a square footage calculation basis, which I think is really going to be welcomed by everybody because it really simplifies things. So I believe for up to 9 square feet or a fraction thereof, you need one receptacle outlet. And then you need a second receptacle outlet for the next 18 square feet or fraction thereof. So that's the baseline way of determining the quantity of receptacle outlets. At the end of the day, under the 2017 code, like basements, this calculating receptacle outlets for kitchen islands and peninsulas has gone back and forth over the years, but they finally simplified it. It's based on square footage. Under the 2017 code, you only had to have one receptacle outlet regardless of how big that island was. Now, for a larger island, minimally, you're probably going to need 2. If it's a really big island, greater than 27 square feet or something like that. I don't have the numbers in my head. You might need 3 receptacle outlets. But with that change, they also are the code is allowing the designer or the property owner to decide where receptacle outlet go. So the code is not specifying that they have to be in any certain location. In fact, if you did the math and you ended up requiring 2 receptacle outlets for your island, you could put them side by side in a 2-gang box and you'd be in compliance with the code. Or you could put a plug strip under the counter overhang. So
okay,
it's a welcome change in the code, and it's really not going to create any difficulties for electricians or homeowners. The next thing, and with respect to services, 230.67 is the surge protective devices that are going to be required, and that's for dwelling unit services. So this would be 1 family, 2 family, and even multifamily. The requirement for a SPD, we call them surge protective device. And what's interesting is that this is one area in the code where the code is actually applicable retroactively, which is rare. When you replace the service panel at a 1-family dwelling in the future, you'll have to add the SPD protection.
What kind of investment is that, John?
I've got one on my panel, and it was $98. Very modest investment. They're not that expensive. You get what you pay for. So I think mine is rated for 50,000 amps and 1,000 volts. So
which is bigger than most households would ever need.
Yeah, the idea there is that if there's a lightning strike or if there's a surge on the power line, that surge protective device will squelch or clamp down that surge in voltage, that over voltage condition. And it might do that repeatedly. There's a misunderstanding out there when this change came about that the SPD would actually shut off your power, and it was a one-time use and you had to throw it away and replace it. And none of those rumors are true. It's just a small device. It doesn't have any moving parts. It doesn't make any noise. It squelches the over voltage conditions, and it might do that repeatedly for many, many years. If a lightning strike was large enough to exceed the rating of the SPD, then the little indicating light would go out, and that's a clue that, okay, it sacrificed itself in trying to clamp that over voltage, and I guess I need to replace it if I want to continue that protection. The nice thing about SPDs, unlike the plug strip version that we might have our TV plugged into or our computer, a whole house surge protective device is protecting the whole house, including all of your appliances that are not plugged into receptacle outlets, such as the air conditioner and your furnace, and all of the other smart devices in your home, all the way down to smart light bulbs and smart thermostats. When you stop and think about all the electronics in your home, that whole house SPD is protecting all of it,
so
not just what's plugged to a receptacle outlet.
So once I install this SPD in my home, does that mean that I can get rid of my surge protection strips?
I don't know. I don't know if I would do that. There's nothing wrong with leaving them in place. There's nothing wrong with leaving those there. The surge protective devices come in 3 types. The type 1 is the kind that is connected to the supply side of the service. We're not even going to talk about those. Type 2, some are dual rated, type 1, type 2. A type 2 SPD needs to be connected at the panel to the load side of a circuit breaker. It's required to have overcurrent protection, but it does the same job. It's protecting the entire home. The other thing I was going to say about SPDs, we had a situation here in the Twin Cities, probably back in July. There were some pretty nasty storms that went through the east side of the Twin Cities. And I don't know, I won't mention the neighborhood, but this one community north of St. Paul, it was just a confluence of events, but there were several homes in one neighborhood that got struck by lightning. Or the home next door was struck by lightning and they had overvoltage conditions in the house next to it. And these people lost anywhere from $6,000 to $8,000 to $10,000 worth of appliances because of those surge conditions. So,
oh, wow.
yeah.
Can you just say one more time, when is the requirement for this? I mean, you said this is retroactive. What triggers the requirement to get these put in your panel?
Actually, under the 2020 code, when it gets adopted, for new construction, SPDs will be required for dwelling units, one family, two family, multifamily. And you can buy them at the home center as an add-on, but the manufacturers have already geared up to provide those SPDs as part of the panel. So eventually it's going to be like anything else. They'll just become a standard feature in most panels. And then retroactively, it's one of the few places in the code where the code looks backwards, but basically if you go to, say you're going to upgrade your service from 60 to 100 amps or 100 to 200 amps or whatever, if you replace that service panel, then the SPD has to be added at that point in time.
Okay. What about if you're rewiring your entire home? You got knob and tube, you're going to redo it all with modern wires, and you're doing everything except for replacing the panel. Does that trigger the need for one?
No, okay. It's for panel replacements.
And then to flip that question around, let's say you are only replacing an electrical panel. You're upgrading from fuses to circuit breakers or something. Is there any type of requirement to add arc fault protection inside that breaker at the time you're doing that?
If you replace an existing panel with a new panel in essentially the same footprint or the same space, you are not required to bring the house up to code. You're not required to add AFCI protection. I'd have to look up the exact language, but you could even shift that new panel, put the new panel next to the old panel, and then do your rewiring. And the code, there's, I think 6 foot is the increment. You can extend those existing circuits up to 6 feet and not have to add the AFCI protection.
Okay, so, perfect.
Yeah.
This is one that gets confused a lot. A lot of people are concerned about replacing their panels because they think they're going to have to add all this new stuff in the panel and throughout the home. And what you're saying is what I've always understood, mostly because you've told me this before. But I want other people to hear it.
Well, it's been my experience. My mother-in-law's condo, we replaced a panel. They didn't require arc fault. I just replaced a panel in my house last year, and we didn't have to add a bunch of arc faults. 1941 house.
Well, yeah, this is a little off topic from, what's coming down the pipeline, but I wonder if you've heard of this. I saw a post on a Facebook home inspector forum about a guy who leaned his ladder up against the side of a house, and he was getting on the roof to inspect it, and he had the ladder leaning against, the vinyl siding. He said when he got up to the gutters and he leaned over the gutter, he got a really bad shock from the gutter. And there's some other inspectors that chimed in and said, yeah, I never lean my aluminum ladder up against a gutter or against aluminum siding without checking first to see if there's any voltage, and they use their little voltage sniffer. I personally have never done that. I've never checked a gutter with my little voltage sniffer or anything before I lean my ladder against it. Is that dangerous? And how often does that happen, and what could be causing that?
All right. And you know what? Before John gives his professional answer, I'm going to give my unprofessional opinion. I think doing that is just insane. And what metallic component in a home are you comfortable touching before using an electrical sniffer if you're not comfortable touching a gutter? I think you've lost your dang mind if you're going to touch everything with your sniffer before touching it with something else. But now we'll let the real expert answer the question, John. Go ahead.
Well, it's kind of an open question. It could be so many different things. There could be a ground fault condition somewhere in or on that home that the fault current is not high enough to facilitate the tripping of the circuit breaker or blowing the fuse. And we can touch on that just a little bit. It seems counterintuitive. We've bond and we ground our systems, and you guys are familiar with the equipment grounding conductors that are part of every branch circuit that's run. And those equipment grounding conductors, under normal conditions, are not a current carrying conductor. They do not carry any current. All the current is carried on the insulated conductors. But in a fault situation, in a ground fault situation, that equipment grounding conductor needs to be a low impedance, a low resistance path, because you actually want lots of current flowing to trip that 15 or 20 amp circuit breaker back in the panel. So you could have a low level ground fault condition where, use my brother as an example, the metal shell of that old freezer was energized, but it kept working and it didn't manifest itself or impact anybody or anything until he came in contact with it. And that could be the situation with that siding and gutter situation. You could have an outdoor light. You could have a pinched wire somewhere. And when that light is on, it's energizing the gutters and the siding of the house. And then to get really bizarre, I saw a house in a suburban community here in the Twin Cities that was just under the right-of-way, just outside of and under the right-of-way of transmission line. And there was enough electromagnetic interference coming from that transmission line that it was inducing a voltage on their aluminum siding.
What?
Soffit fascia.
Wow.
And the only way to mitigate it was to have an electrical contractor come out. They didn't put in a full, like a lightning protection system, but they grounded all that metal surface on that home to bring everything back down to as close to zero potential or 0 volts as they could. So,
Ruben, you want to retract your statement earlier about the voltage sniffer?
No, absolutely not.
The only reason I share that story, and I don't know if it'll be part of the podcast, but it just goes to show you that it could be these electrical anomalies. It could be a nicked wire, or it could be something otherworldly that you would never think about. And that happens a lot on farmsteads. Stray voltage is a major problem on farmsteads. And that stray voltage, it could come from just about anywhere. It's a matter, again, of troubleshooting, finding the source, mitigating or eliminating the problem.
I've heard a lot of problems with farm animals getting killed by getting too close to stray voltage. And I mean, so what's our solution? You don't walk on the earth unless you have a tick tracer? I mean, this is the natural progression to this line of thinking. That's my thought. So
Life is dangerous.
Yeah.
Well,
that's all.
Electricity is a phenomenon, and we can create it and we can put it to work, but unless there's an arcing event, we can't see it. So it truly is a phenomenon, and it's a tool. We put it to work for us, but it'll turn around and bite us when we're least expecting it.
So I'm sorry, we keep getting you off topic here, John. We're trying to get through a few of the bigger changes. So you talked to us about SPDs. Is that what you said? Surge protection devices? Yep. Those are going to be required in panels.
Yep. So let's move on to the emergency disconnect. The emergency disconnect.
Yeah.
The code has always allowed for the service disconnect to be on the outside of the structure. That's been forever in the code. In fact, you could have the service disconnect for your structure. That service disconnect might be 100 yards away at the lot line, because a lot of utilities will only bring their infrastructure to the lot line. They'll set a meter pedestal, and it's up to the homeowner to bring that wiring to the home. And it could just be underground service conductors, unfused service conductors, and then you establish service at the home, or that pedestal out at the lot line might actually be the service equipment, and you run a feeder to the home, establish your panel, et cetera, et cetera. But the code has always allowed for that infrastructure to be outside, and that's actually where it's best located, especially if we're talking unfused conductors. But the need for an argument for an emergency disconnect for all 1 and 2 family homes originated in the first responder industry, primarily the fire responders. And we've got requirements in the code. If you got an outdoor generator, there's got to be a disconnect available, readily accessible. If you got solar PV system, there's got to be a readily accessible disconnecting means. So for all these other things, these other types of electrical installations outside of our home, there's already a requirement for a disconnecting means. So it just made sense for there to be a requirement for a whole house emergency disconnect. And it's very common. And you go into the southern United States, they actually put their panel boards outside. I wouldn't be in favor of that. But so that emergency disconnect, it seems like a big leap in the code, but when you stop to think about it, it's actually a pretty good idea. I mean, think about a first responder showing up, or, it gives you, the homeowner, an opportunity to shut off the power to the home in an emergency. If you're a homeowner and you're do-it-yourselfer and you want to remove that panel cover at your home, if you don't have that emergency disconnect, when you pull that panel cover off, the panel's still hot. Even when you turn that main breaker off, that panel is still hot on the line side of that main breaker. There's lots of, after the initial excitement and consternation, it's like, let's stop and think about this. It's actually probably a good idea. And what's it going to look like on the outside of your home? Instead of this gray enclosure that only contains a meter, you're going to end up with a gray enclosure that has a meter and a circuit breaker in it. So aesthetically, it's not a deal breaker. It's all going to work out fine.
Now, John, let me ask, because I heard an electrician tell me this. I was saying, so now that you need the service equipment at the outside, it means that any panel you're going to have on the inside is going to be a sub panel. And he corrected me and he said, well, there's no requirement to have the service equipment at the outside. It's actually, you just need a disconnect. So if they choose to not have overcurrent protection, it's not a circuit breaker, it's just a switch, then you can still have your main panel inside the home. Is that correct?
Yep. Yeah. There's 3 different options in the code as to how you want to do this. That emergency disconnect may just be a supply side disconnecting means, and it would be labeled emergency disconnect, not service equipment. And then there's a hybrid version of that. You might choose, like I just said, the combo meter main, where you got the meter and you got a main breaker in there. That in effect becomes your service disconnecting means. And then you would have a feeder to your panel board, and your panel board then wouldn't need a main breaker in it. It would just be the branch circuit breaker. So there's lots of options for getting this done. Electrical contractors are going to use their ingenuity. They're going to do what they need to do to comply with the code and make it as cost effective as possible. It seems like a big leap, but I think at the end of the day, it's going to turn out to be a good thing. So vandalism, people have expressed concern about vandalism with this outdoor emergency disconnect. There's nothing in the code that prohibits you from locking it in the on position. And in addition to that, if it's a meter main, meter circuit breaker combo, there's going to be a cover on that piece of equipment, and you can throw a padlock on the cover. So now you got 2 padlocks on that equipment that mitigate any opportunity for people to vandalize it in any way or to shut off your power.
Because you see those on the outside of apartment buildings or condo or townhouse communities all the time.
Yep.
Anybody could open that and shut off somebody's power. I'm not sure they want.
Yep.
Okay.
The next code change, again, this has gone back and forth in the code. At one point in time, the code required you to extend a neutral conductor to every switch box, essentially, where there was an overhead box that could accept a paddle fan. Jumping ahead, most ceiling fans today only need a hot and a neutral. And then you've got a remote control, you've got wireless opportunity to turn the lights on and off, turn the fan on and off, to adjust the fan speed, etc. So they've simplified, they've eliminated a lot of those extraneous requirements that would require extra wires to be run to switch locations and whatnot, and to ceiling locations. So what has changed in the code is they've basically said we want a ceiling fan rated box at every location where a fan could be installed, or something to that effect. And of course, on the outside, it's like, oh my gosh, I got to buy this $12 listed fan box and to be used for every location where there's a ceiling fixture. Well, the code, there's a provision in the code that says you got 2 options. You can install a listed ceiling fan box, or you can provide a means by which that ceiling fan can be secured to the structure. So forever, what electricians have done, they've just taken regular electrical boxes or little pan boxes, the 1/2-inch pan boxes. They've used standard electrical boxes, but they've attached those boxes to a wood brace or some sort of structural support, so that when that light fixture ultimately is replaced with a ceiling fan, the ceiling fan will be secured to the structure and the box is just there to contain the splices. That hasn't changed. And again, it's not a deal breaker. At first blush, first glance, it looks like it's an overreaching requirement in the code, but really it's not a major change at all. Moving on. Receptacles in bathrooms. For years, there's been a provision in the NEC that has restricted light fixtures, certain types of light fixtures, in a zone measuring 3 feet by 8 feet for bathtubs and showers. A wall sconce is fine. A pendant light is not. ceiling fan is not okay. Obviously, recessed lights are fine. So the safety concern is that somebody in a shower or bathtub zone, if they slipped and fell, they might reach and grab something that, provide electrical hazard. So all they've done is they've just taken that same concept and applied it to receptacles. So lights have this 3 foot by 8 foot zone. There's restrictions relative to lighting fixtures. And now we have that same zone concept for receptacles. Still need a receptacle within 3 feet of the basin, but it can't be in that 3 foot by 8 foot zone. And if the bathroom is too small to accommodate that, then there's an exception in the code that says just put it on the wall farthest away from the bathtub or the shower. So it's a matter of dealing with a gap or an omission in the code, because quite honestly, there was nothing preventing you before. You could have if you had a bathtub and you had some wall space and you had a basin, there was nothing stopping people from putting a receptacle on the wall within reach of that bathtub. Why does it even need to be there? That kind of a thing. But there was no rule in the code that prohibited it. So now they put that language in the code, again, for safety purposes.
Well, guys, we could go on and on. I have one question, but I'm not going to ask it now. Well, I'm not going to ask you to answer it now, but I am going to ask it. What happens to electricity after it's created and it's not used? Does it just keep circulating around until it gets used? Or does it dissipate? Or does it just evaporate? These are deep questions I have, but don't answer them now. Next time we'll talk about that. How's that?
Yeah, we're gonna have to do a part 2. And I've still got more questions.
Yeah. We're gonna wrap this episode up. Thank you, John, so much for spending some time with us. You are now going to be the person we call on a regular basis to join us. So we've got Andy, and I want to put him on a regular turn. So thank you very much for your time today. You've been listening to Structure Talk. My name is Bill Ulrich, alongside Ruben Saltzman and Tessa Murray, as always, and we will catch you next time. Thanks for listening.
For more information on how we can provide you with the right information about your home before you buy or sell, contact us at structuretech.com.